Okay, also in 7.2, we could find x values given a z-score. Finding normal values, the x, from a given z-score from a normal distribution. So we take our z-score formula and we're going to solve it for x. We've done this in previous units. So the x is going to equal the z-score times standard deviation plus the mean. So for an example, heights in a group of men are normally distributed with a mean of 69 inches and a standard deviation of 3 inches. We're going to find the height of a man from this distribution whose z-score is positive 0.6. That means 0.6 standard deviations above average for this distribution. So 0.6 standard deviations, standard deviation is 3 above average, is gonna be a man who's 70.8 inches tall is 0.6 standard deviations above average for this normal distribution. So finding the normal values, or the x, in this section, what we have to add to it is now we're going to be using our yellow table to get that z-score for a given percent. So for example, Mensa is an organization whose membership is limited to people whose IQ is in the top 2% of the population. Assume that the scores on the IQ test are normally distributed with a mean of 100 and a standard deviation of 15. We're going to find the minimum score, the x, needed to qualify for membership in Mensa. So we have this normal distribution, and we know the top 2% that this is going to be the cutoff. So we're going to find this x, but first I need the z-score that matches with this. So the area under the table is 1. If I minus 98, I get 0.02. So I'm going to use my yellow table and I'm going to read it inside out to get the z-score when 0.9800 of the area is shaded, so that we're left with the top 2. So I'm going to use my yellow table inside out. I need the closest number I can find in the table to 0.9800. So I'm definitely well over 50%, so I'm on my positive z side. And what I'm doing is I'm looking at the area inside for the number closest to 0.9800. So here I have 0.9798. Here you have 0.9803, a little above, a little below. This, if I take .9798, this is only 2 10,000ths off. This one's 3. So this is the number closest to 0.98. So the z-score that goes with that is going to be 2.0, and it's at 5. So we use the yellow table to get the area closest to 98%. That was 0.9798, so our z-score is 2.05. So to solve for the actual x value, I'm using my x formula, plugging in 2.05, standard deviation of 15, we add the mean, so that gives us an x value, or a score, of 130.75. So since the scores, IQ scores, are generally whole numbers, we'll round this to 131. So 131 is the cutoff to get into this group. Okay, so we'll do another example. Again, we're finding the normal value, or the x, for a distribution. So if we have a normal population with a mean of 12 and a standard deviation of 3, we're going to find what's the x at 40%. What is the 40th percentile of the population? So I know I'm going to be solving for the normal value, and I'm going to use my table to get the z-score that is closest to 40%, or 0.4000. So I'm looking inside my table to find out what z goes with this, the area closest to this that I can find in my table. So because I'm below 50, I'm going to be on the negative z-score side. I'm below the mean, so I'm literally looking for the number closest to 0.4000. So these two right here are going to be the closest. I have one below it and one above. So this one's 13 ten-thousandths off. And this one's 26 ten-thousandths off. So we're going to go with this is closest to 0.4000, 40%. So the z value that goes with that is going to be negative 0.2, and then we're going to go up. So it's negative 0.25. So negative 0.25. 0.25 standard deviations below mean is 40% of the way of the area under the curve. But what is the x value for this normal distribution that goes with that? Standard deviation of 3, and I'm going to add it to the mean. Negative 0.25 times 3 plus 12. So at 11.25, we're 40% of the way, or 0.25 standard deviations below mean for this normal distribution.